In the upcoming lessons, we're going to be talking more about the structures of compounds. And we're going to start with a discussion of ionic compounds. In this video, I want to give a short overview of these structure types and also how that relates to their properties. Recall that these ionic substances are composed of ions, which are atoms or molecules that have gained charge either through the loss of electrons to form positively charged atoms or molecules, or gained electrons to form negatively charged species. Examples include sodium chloride, magnesium oxide, and calcium fluoride. The properties of each of these ionic compounds include high melting points. So, for instance, sodium chloride has a melting temperature in excess of 800 degrees Celsius. Magnesium oxide, even higher melting temperature above 2800 degrees Celsius. They're also all characterized by the ability to conduct electricity when in the molten state, in other words, when melted, or when dissolved in water. And then finally, solubility is a common property among many salts. However, the degree of solubility is dependent on the exact salts. So some salts are very soluble in water, while others are only weakly soluble in water. So to understand these properties a little bit better, we want to look into a little more detail about the structure. Of course, the first thing is that they all are composed of ions, as we mentioned. Sodium chloride is composed of Na plus and Cl minus, in which sodium metal has lost an electron to form Na plus, and chlorine has gained an electron to form Cl minus, or chloride. Of course, the fact that these are composed of ions with positive negative charges explains why they can conduct electricity when these ions become mobile in either the molten or aqueous state. Magnesium oxide is composed of Mg2 plus magnesium ions and oxide O2 minus, and then calcium fluoride. That structure refers to a 2 plus calcium, so 2 electrons remove calcium to form Ca2 plus, and 2 fluoride ions, each carrying a -1 charge. The positively charged ions are called cations. The negatively charged ions are called anions. And in the structure, these opposite charges attract, and so the electrostatic force holds together, for instance, in magnesium oxide, the magnesium 2 plus and the O2 minus. And this force of attraction in these ionic compounds, since they're ionic compounds, is called an ionic bond. So we have a strong force of attraction, electrostatic force, the tug of the 2 plus charge to the 2 minus charge in the case of magnesium oxide, which holds the structure together. However, an ionic compound is not as simple as a single interaction between for instance, a single sodium ion and a single chloride ion. Taking that as the example, NaCl, we see here a crystal of sodium chloride, and if we look more closely at the structure of this crystal, we see that it's actually composed of a network, an extended 3D network of these oppositely charged ions. In this cartoon, the purple spheres represent the positively charged sodium ions. So we have positive sodium ions in the purple. The negative spheres represent the negatively charged chloride ions in the structure. This extended 3D network of oppositely charged ions in this solid is called the lattice. So these ions come together to form a lattice, And of course, what's really cool about this structure is you see the cubic structure in the cartoon, and then the actual crystal structure that we observe with our eyes also has sort of a cubic like structure. So what happens on the small scale is propagated, and we observe on the larger scale as well. The lattice is extremely strong because of the sum of all the attractive forces between the positive and negative charges in the lattice. So in other words, we don't have if we look at any one positive ion, we see that it's actually surrounded by several negatively charged chloride ions. And each individual chloride is surrounded by several positive charges of sodium ions. And this leads to a very strong structure and explains the very high melting points. So they always have a long extended network of these ionic bonds in the solid, and therefore very high melting temperatures for these types of substances. Of course, there are also repulsive forces in the structure. Negative charges repel, and the positive charges repel. But the net stability, the sum of these attractive and repulsive forces, is still a very strong structure with very high melting temperatures. And now finally, talk about the empirical formula for these compounds. The formula for salts is based on the ratio of ions in the network. So in other words, this empirical formula is based on the balance of charge in the structure. In the case of sodium chloride, there is one sodium chloride ion in the lattice for each chloride. And so the charge is balanced. One sodium per chloride gives a neutral salt, and therefore the empirical formula of NaCl.